Hello, welcome back. Today we're going to talk about two more special centers. So, if you recall, we talked about the centroid, or I'm sorry, not the centroid, we're doing that today. We talked about the circumcenter, which is where the perpendicular bisectors meet. Perpendicular bisectors. We also talked about the incenter, which is where the angle bisectors meet, this point of concurrency. Today we're going to talk about the centroid and the orthocenter. So first I want you to plot ABC, and I want you to find the midpoint of each side and draw the medians. Remember, medians go from the vertex to the midpoint. So please pause and do that. Okay, welcome back. So you can see that I found my midpoints. And then the midpoint of AB is 5, 3. Midpoint of BC is 8, 4. And the midpoint of AC is 5, 5. I then drew the medians, which is from the vertex to the midpoint, which I'll label. And so let's say BC was point D, AB is point E, and AC is point F. So AD, CE, and BF are all medians, and they intersect at one point. This point is called the centroid. And the centroid in this case is 6, 4. Now, the theorem is the medians of a triangle intersect at a point of concurrency the centroid is 2/3 the distance from the vertex to the midpoint. So what that means in this case is if I name the centroid G, is that AG is 2/3 of AD. This is an important fact, and that BG is 2/3 the length of BF, and that CG is 2/3 the length of CE. This is very important. So, if M is the centroid of triangle WR and WM is 16, I want to find WX. So I know WM is 2/3 of WX because M is the centroid. So that means 16 is equal to 2/3 of X. So I multiply both sides by 3/2, and I find out that X is 24, which is WX. So then if I know YM is 12, find YO. So if OM is 2/3, that means YM is 1/3. So YM equals 1/3 of YO. So 12 equals 1/3 of YO, which means 36 equals YO. Now, another way you can think about doing both of these is that if WM is 2/3, then MX is 1/3. Well, 1/3 is half of 2/3, so that means mx is 8, which would make wx 24. Likewise, if ym is 1/3, om is 2/3, so om is 24, which would mean the whole thing's 36. And mo is then 24. So I want you to pause, and I want you to try number 2. Okay, I'm going to try to pick this up where I left off. So I know that G is the centroid because it's where the medians intersect. Therefore, I know that BG is 2/3 of BE. And therefore, GE is 1/3 of BE. And also that means that GE is half of BG. So I said 3x minus 1 equals 1/2 of 2x plus 10. I solved that and I found x equals 3. And then substituted 3 into GE and I got GE is 8. So then BE is 24. So now I want you to pause and try try this example. Sorry, not the last example. To find the coordinates of the triangle ABC. Find the midpoint of BC is 7, -2. Okay, so since I'm looking for the centroid, which is 2/3 from A to B, what I want to do is I want to partition. So I want it to be the ratio of 2 to 1. So if I'm doing it graphically, from A to D horizontally is 6. So I divide it by 3, which means each section is 2 units. So from A, I go over 4. So I do 1 plus 2 times 2, which gives me the x-coordinate of 5. From A to D vertically is 9. So I do 9 divided by 3. So then I want to do 7 minus 3 times 2. And I know that I want to do minus because I need to go down, which gives me the coordinate 5, 1. If I use my formula, I do 1 times 1, which is the A coordinate, plus 2 times 7, which is D, the N coordinate, divided by 3, comma 1 times 7, which is the Y coordinate of the first point, plus 2 times -2, which is the Y coordinate of the second. And I also get the answer 5, 1. The orthocenter is the point that the altitudes meet. Point of concurrency for the altitudes. So when I am looking at the altitudes of an acute triangle, remember an altitude goes from the vertex and makes a right angle. Acute triangles, it will always be inside. So the orthocenter will always be inside. On a right triangle, it's always going to be at the right angle because 2 of the altitudes are the legs, and then the altitude from the right angle to the hypotenuse will also intersect. So it is at the right angle vertex. When I'm talking about the altitudes of an obtuse triangle, they are always going to intersect outside the triangle. Now the orthocenter is the least special of our shapes, or of our centers. So find the coordinates of the orthocenter of the triangle with the given vertices. So I want you to pause and plot it, and then come back and we'll work on finding the orthocenter. Okay, so here's my drawing. You can see that it's a right triangle because one of my sides is vertical, my other side is horizontal, and they intersect at Q. So that's the right angle. So Q is the orthocenter because all right triangles intersect at the orthocenter. If I did not remember that, I would want to find the altitudes, which are always perpendicular to the side opposite. So if I wanted to find the altitude of PR, I know that the slope from P to R is up 6 over 6, so it has a slope of 1. So my negative slope, my negative reciprocal is the slope of -1, so I want to start at Q, which is the vertex opposite, do a slope of -1. I would do that for the other sides and look for where they cross. If you have any questions, please bring them to class.